Oh hi, didn't see you there, and welcome to my calculus project. My project is on butterfly knives. Now, you may be wondering, Zach, what is a butterfly knife? Well, it's this. It's got two handles, and it's got a blade, and you can spin it around. Now you may be wondering, how will I be able to do calculus with a butterfly knife? Now let me tell you. What I will do is I will take a slow motion video of this flip and break it down into parts. With those parts, I will find its angular velocity, and then from the graph of that angular velocity, I will find its derivative and determine its angular acceleration. To define these parts that I mentioned, it is whenever the butterfly knife stops moving in one direction and moves back in the other direction. So let's get right into the slow motion video. The reason the flip was taken in slow motion was to allow for a more precise measurement of time. Therefore, the calculations done are not of the knife at full speed. I used the equation for radial velocity, which is delta theta over delta time. This allowed me to create the following graph. This graph shows my calculations for angular velocity at different parts of the flip. The specific equation for this graph is negative 4.33 times x squared plus 0.76. To get angular acceleration, I must take the derivative of this graph, which turns out to be negative 8.66 times x. Then, to find the average angular acceleration, I must use the equation f prime of x minus f prime of a over x minus a. And when I do this, the average angular acceleration of the knife during the flip turns out to be 8.66 radians per second squared. And that concludes my calculus butterfly knife experiment/project. I want to thank you all for watching, and most importantly, I want to thank Mrs. Manlove for teaching me this year, as well as allowing me to make this project.